As is often the case, we'll follow the major headers in the text, but of course elaborate where we can. Some traditional approaches to the study of memory, of course, include that modal model, and that's why I referenced it in the title. But I should review some terms, and these are kind of direct, but it's worth touching base on. A brief review of the terms before we begin. We could say that encoding occurs when information is translated into a form that other cognitive processes can use. For example, even when we're reading letters, it's going to be the case that there's a verbal encoding. So if I read letters in a row, XPW, even though I'm just reading them, I've got a verbal encoding of sorts. I can sort of hear it in my inner ear. And it'll be confusing if I have PCD, because all of those letters rhyme. We'll see an experiment that relates to that. We'll call a formation of a memory trace. This trace is held in storage in one form or another for later retrieval. And we'll say that forgetting occurs when we can't retrieve that information, as we'll speak of. Why does forgetting occur? Is it just the mere passage of time, or is it some interference? For example, in my in-person classes, I have trouble remembering the students that were here just last semester sometimes, because I've got all new students now in those same chairs. Now, that's not any insult on the people that were here before. It's just a matter of one group of students replacing the other. And that's kind of a tough thing. So that's an impediment. That's something that we would describe as interference. Now, here's that old model of memory. I think I had a more elaborate model before. But of course, we have senses, basically like a Tempur-Pedic mattress. Senses leave some impression on our vision. And you can imagine a sparkler, a fireworks sort of thing on 4th of July, waving it in the dark, and it leaves a trace of itself. I can draw a box or a figure eight or what have you. That's just an iconic sensory memory. In addition to that, there are echoic, where you hear the reverberation of a sound. So without warning, if I said something out loud to people, XPW 509, in that case, they could recall it back because they have some reverberation, much like the impression that your hand leaves on a Tempur-Pedic mattress. And then it sort of writes itself as a few seconds go by. And then short-term memory, we hold things aloft so that we can use them later. They don't last forever, but if I rehearse enough, those things will wind up in long-term memory. A major difference between short-term and long-term memory is that short-term memory is pretty finite. We don't have infinite capacity there, whereas long-term memory is essentially infinite. There's really no upper limit on the things that you could commit to memory if you chose to, whereas short-term memory, if I'm just using numbers or letters or information to do a task, or if I have to repeat a series of numbers or letters, that's pretty difficult to do when it gets past 7 characters or so. So this model dates to the 60s, 1968. Getting up there in years now, 56 years, but it has lasted the test of time because it's so intuitive. Now, we assume that information is received, processed, and stored for each kind of memory. And there's the Atkinson and Schifrin in 68. Unattended information presented very quickly is stored only in sensory memory. Attended information goes to short-term memory for a few seconds. So, for instance, the first time that you heard a squared plus b squared equals c squared, it wound up in short-term memory after it was in your sensory memory. You had to hear it, but then you bandied it for a while and tested it, and maybe did a 3, 4, 5 triangle, things like that. And then eventually, information needed for longer periods, the correct spelling of words on a test or the formula for the test, a squared plus b squared equals c squared, winds up in long-term memory. Now, that may come from sheer rehearsal, or it may come from elaboration, as we'll talk about in a future chapter. If I can make a silly rhyme up, like, my very educated mother just served us 9 pizzas, to help to learn the name of the planets. Now, there's a recall experiment that suggests that there may be some validity to this, and it has to do with primacy and recency. So the participant's job is to remember in order these 20 words. that are said to them verbally. So I might say, hey, participant, I'm going to read a word to you every 5 seconds. And I want you to do the best you can to recall it in order, or in any order, really. We'll see how we do. So for the first word, table. And then another 5 seconds, candle. Another 5 seconds, maple. And so what's the participant doing? They hear table and they're repeating it over and over again. They're rehearsing it. Then candle, table, candle, table, candle, table, candle. Then maple, table, candle, maple, table, candle, maple. These first words have the advantage of being rehearsed over and over again. The latest words, like letter, turkey, and hammer, have the advantage of being very recent. So the first words enjoy the primacy effect, where they have a lot of rehearsal, a lot of ensconcing, if you will. They're dug in because they're the first ones. Sunshine, letter, turkey, hammer are very recent, and they're recalled better of the 20. But then the words in the middle enjoy neither benefit. They're not recent, and they're not rehearsed particularly much, and therefore there's a dip in the words that we tend to recall later. And that is suggesting of the primacy and recency effect, which to some degree speaks of short-term and long-term memory due to rehearsal. So there's been a fair amount of endorsement of this modal memory model, but this oft-cited experiment is one piece of evidence, if you will.